Early in 1960, spin test modifications were completed on YT-38 58-1191. Special instrumentation, a spin chute package, aft fuselage strengthening longerons, and an emergency battery-operated hydraulic system for use if both engines flamed out were installed. Chute deployment and jettison tests were conducted on high-speed taxi runs and during landings to verify chute stability and structural integrity. Spin entry development quickly demonstrated the airplane's resistance to conventional spin entry techniques. Furthermore, though the spin mode was occasionally approached, it was difficult to sustain. Finally, on Flight 115, at 140 knots in a 40-degree pitch attitude, the application of full left rudder and right aileron with 0 degrees horizontal stabilizer caused the airplane to enter an inverted spin. After 2 turns, it transitioned to an erect attitude. Due to the rapid loss of altitude in the inverted and transition portions of the maneuver, little time was available to investigate spin recovery techniques, and the pilot deployed the spin recovery chute at the prescribed safety altitude of 20,000 feet. The inverted mode resulted from 4 of the next 23 entry attempts. With one exception, however, the spin could not be sustained more than 1.5 turns. NORAIR NASA analytical studies and flight test experience having indicated certain control inputs from a nose-high inverted attitude would be favorable to the development of erect spins, emphasis in succeeding flights was placed on inverted entry attempts. Usually, the spin could not be sustained more than 2 turns before degenerating into a steep spiral. The inverted entry technique frequently resulted in erect spin initiation, but with 4 exceptions, the familiar degeneration into a steep spiral came after no more than 2 turns. 5-turn spins were obtained 3 times, with maximum yaw rates ranging from 70 to 90 degrees per second. In each instance, recovery was effected in 2 turns or less after the application of predicted recovery controls. A 7-turn spin on Flight 162 was the most fully developed of the series. Very flat and steady, it had a maximum yaw rate of 115 degrees per second. Recovery controls were held for 3.5 turns, but since full control had not been regained upon reaching the 20,000-foot minimum safe test altitude, the spin recovery chute was again deployed. The aerodynamic drag and added weight of the spin chute package, external longerons, and derated YJ85-1 engines made altitudes above 30,000 feet impractical for the test airplane. Dash 5 afterburning engines were therefore installed in the airplane. Not only would these engines raise the entry altitude above 40,000 feet, but because of shorter climb time and consequently reduced fuel expenditure, would permit 5 or more spin entries per flight. To date, attempts to enter a spin from wind-up turns in the clean configuration, with the landing gear down and the flaps and speed brakes at various positions, demonstrated no spin tendency. Application of pro-spin controls did in no instance generate a spin. Similarly, no spins were obtained from zoom entries or Immelmans. As in the earlier phase of the program, erect spin tendencies were not exhibited in any entry maneuver except the inverted type. From inverted entries, the erect spin mode developed approximately 2/3 of the time. However, in only 27 of the 66 developed modes could the spin be sustained even with pro-spin controls. To the end of the year, the spin test program has demonstrated no T-38 susceptibility to spin entry from any maneuver except the inverted entry, and has indicated that the airplane has no tendency to spin from any anticipated service maneuver.